Amount of substance questions are very common in paper one. They come as titration, whether it's acid-base titration or redox titration. Last year exam, there were two different questions related to the amount of substance. One of them was the redox titration, and the other one was a simple acid-base titration. However, these questions in paper one usually come with a lot of text, a lot of steps that confuses the student. So I'm going to break down one of these questions for you and simplify it for you so you can answer it properly with no issue. So this question was from 2024 paper one, and in this question there is a lot of text here, as you can see. However, I'm going to just simplify what happened. So first of all, they were making a saturated solution of strontium hydroxide in water, so they kept adding strontium hydroxide until no more dissolved. They filtered the excess, took 25 centimeter cube from that solution and titrated it with hydrochloric acid. The concentration of hydrochloric acid was the 0.1 mole per decimeter cube, and then they took the titer and they're asking you now to calculate the solubility of strontium hydroxide as gram per 100 centimeter cubed. So in this question, first, they are asking you to write the equation for the reaction between strontium hydroxide and hydrochloric acid. This is quite important because you're going to use it in your calculation. Strontium, of course, is group 2. So the strontium hydroxide, which is group 2 plus HCl, that will give you strontium chloride plus water. And then they give you this table with the different titers and asked you to give the mean titer. There's always a rough titration one. We're going to exclude this one. And then we always end up with these three. We're not going to use all the three. We're only going to use the two which are very close to each other. So you can see this is 32.45, this is 33, and the last one is 32.40. So we're only going to take the first and third one, and we're going to ignore the one in the middle. We're going to take the average of these. So this is going to be 32.40. It should be 425, but we only need four significant figures, so it's going to be 43. Okay, so now we know the mean titer. When you do this type of calculation, you start backwards. So you start from the last step and go upward towards the first step. So they want you to calculate the how many grams of strontium hydroxide was there or dissolved in 100 centimeter cubed of water. So I'm going to start from the last step, which was the titration. So they took 25 centimeter cubed of strontium hydroxide and they titrated it with hydrochloric acid. So the first thing I need to find is the number of moles of hydrochloric acid in that titer. So the number of moles, we know that moles will equal the volume in decimeter cubed times the concentration. So the concentration is 0.1, and then the titer is 32.43 centimeter cubed. So this is going to be converted into decimeter cubed. So times 10 to the minus 3, and that will give you 3.24 times 10 to the minus 3 moles. Now, looking at the equation we just wrote, you can find that 2 moles of HCl react with 1 mole of strontium hydroxide, and we used 25 centimeter cubed of strontium hydroxide. Now we need to find the number of moles of strontium hydroxide in the 25 centimeter cube. That will be half the moles of HCl. So I'm gonna half this value. So this is 1.62 times 10 to the minus 3. Now, the next step, we need to find the number of moles of strontium hydroxide in 100 centimeter cubed, because we need to convert these moles into mass. So now the number of moles of strontium hydroxide in 100 centimeter cubed of our sample, which is going to be 4 times this value because this was in 25 centimeter cubed. So multiply this by 4, and that will give you 6.48 times 10 to the minus 3 moles. All of these are moles, of course. And finally, the last thing, you need to calculate the mass of strontium hydroxide in that 100 centimeter cube. So first of all, you need to find the MR, or the relative formula mass of strontium hydroxide. You can find these from the periodic table. And the MR is 121.6. So now we need to calculate the mass. We know that mass equals N, or the number of moles, times the MR. So 6.48 times 10 to the minus 3 times 1 to 1.6, and that will give you the mass in grams, so 0.788 gram. So it's not 0.788 gram per 100 centimeter cube. So now the solubility of strontium hydroxides is not 0.788 gram per 100 centimeter cubed solution. This is another question from the same paper, but this question, which is also amount of substance, but this is about redox titration. Again, it comes with a lot of text, and we need to simplify this text into the important step. So first of all, they provide you with a certain sample with a certain mass, which is 0.151 gram of impure NH4VO3. And then there are several conversions, and you only need one of these steps. So first of all, the VO3 minus has been converted to VO2 plus ion using sulfuric acid. And then the VO2 plus ions was then reduced with zinc to give you the V2 plus. And then the important bit is the titration. So the titration, and the important step for us now, is the oxidation of V2 plus with manganate, MnO4, minus to give the VO2 plus again, plus the manganese ion, Mn2 plus. So the important one is this one. And the ratio between the manganate and the vanadium is the important one that we are going to use. So there are 3 manganate reacting with 5 of the vanadium. They already provided you with the balanced ionic equation. So, or the redox equation here. So you don't need to worry too much about writing these equations. So this is the only important step for us here. Okay, so what we are going to do, they provided us with 2 things related to the manganate. The first one is the concentration, which is 0.02 mole per decimeter cubed, and also the endpoint, or the titer, which is 29.43 centimeter cubed. Now we're going to work backward as well to find we need to determine the purity of the sample. So basically we need to determine the mass of the ammonium VO3 in the sample provided. So we need to determine the number of moles and convert that into mass. So first of all, we need to determine the number of moles of the manganate, and the moles will equal the concentration times the volume in decimeter cubed, so 0.02 times 29.43 times 10 to the minus 3. That will give us the number of moles, which is 5.89 times 10 to the minus 4 mole. This is the manganate. And then now let's determine the number of moles of the V2 plus. And the moles of V2 plus, as you can see the equation, is 3 moles manganate with 5 mole V2 plus. So now it's 5 over 3 times the 5.89 times 10 to the minus 4, and that will give you 9.81 times 10 to the minus 4 mole. So this is the moles of the V2 plus. The moles of V2 plus are exactly the same number of moles of the ammonium VO3. So exactly the same, because it's only one vanadium anyway. So that means this is also the number of moles of the NH4 VO3 in our sample. It's also equal 9.81 times 10 to the minus 4. Now we need to find the MR of this one. So MR equals 116.9. You can find this value using the periodic table provided for you. And then finally, we need to find the mass. So the mass equals MR times the moles. So 9.81 times 10 to the minus 4 times 116.9. That will give us the mass. So this is 0.1147 gram. Now the next step is to find the percentage purity. So percentage purity will be this value we found, the amount we found, 0.147 divided by the total mass of the sample, which is 0.151 times 100, and that gives you 76%. And they said give it to a three significant figures, so it's going to be 76.0%.